So this lesson is about absolute value. We are going to look at the graphs of absolute value, and we're going to talk about the transformations of an absolute value graph as well as an absolute value equation, what that looks like, and how we can work with the functions to do different things. So an absolute value, first of all, function contains a variable within the absolute value sign, and the graph will always form a V. So anytime you see something with like y equals absolute value of x, or you might see f of x equals absolute value of x. Anytime that x variable is inside those absolute value bars, we have an absolute value function, and the graph always forms the shape of a V, okay? The parent function for absolute value is just simply f of x equals absolute value of x, and it's graphed like this. Now, there's a couple things I want you to notice. First off is the vertex. The vertex is that point at the bottom of the V, and that is always with the parent graph at 0, 0. However, it can move around. The vertex is really important because the vertex is how we orient the graph, and then everything goes off on both sides from that vertex. So that vertex is the most important point. And then secondly is the slope. The parent function has a slope of 1. So you go up 1 and over 1. So notice from the vertex to both sides, you're going up 1 over 1, up 1 over 1. And then to the other side, up 1 over 1, up 1 over 1. Both left and right, you're doing this. And that's what gives you that V shape. So the slope is always the same. It just goes both left and right to give you both of those sides of the V, I guess, if you will. The graph of an absolute value function can be transformed in a multitude of different ways, and we're going to talk about how to do that. The first thing you need to know is that adding or subtracting outside, that's the important word here, outside the absolute value moves the graph up or down. So notice here on this first function, okay, I've got the absolute value of x, and then I'm adding a 2 outside. What that does is that gives us a graph that has moved up 2. So notice from where the vertex was at 0, 0, now it is up 2 and it's at 0, 2. That's a really great way to tell the transformations is see where the vertex has moved. All right. The second one, notice I have the absolute value of x, and this time I'm subtracting 4 on the outside. Just a guess, but negative 4 means I'm going to move down 4. So notice now, to go back to that parent function of the pink one, we've moved the vertex down 4, okay? So adding or subtracting outside that absolute value sign moves the graph up or down, depending on positive is up, negative is down. Adding or subtracting inside the absolute value moves it left or right. Now be very careful because it's the opposite of what you think. Plus inside actually moves the graph left. So this graph, this graph is going to move left 2, left 3. It helps if you can count. Notice that the vertex has moved left 3 because I have a plus 3. This brown one here is minus 1, which means that I'm going to move to the right 1. So again, from that parent function of the pink, we've now moved right 1 to get that brown one. So adding or subtracting inside the absolute value will move the graph left or right, but it is the opposite. So minus moves the graph right, and positive or plus moves the graph left. Another transformation is when we multiply by something out front. And what that does is it stretches or shrinks the graph. Now, we've talked about linear functions and we've talked about slope. Essentially, what we have the number in front is the slope. An absolute value is basically 2 lines instead of 1. And so it has a slope. Generally, it's 1. However, if there's a number in front, it will change that. So a 1/2 out front is actually going to change the slope. So instead of going up 1 over 1, we're going to go up 1 over 2. So it stretches it out to the right. Now notice the vertex has not changed, okay? Because we're not adding or subtracting either inside or outside the absolute value. Multiplication changes the slope. So instead of up 1 over 1, now I'm up 1 over 2 to get each subsequent point. Okay? As you can guess, this 2 is going to change the graph. and it's actually going to make it skinnier. Now our slope is up 2 over 1, up 2 over 1, up 2 over 1. So the number in front is the slope of both sides. And actually, I didn't count to the left, but I can show you that too. Notice the purple is up 1 and to the left 2, up 1 and to the left 2. The reddish one is up 2 over 1, up 2 over 1 to both sides, okay? So that slope applies to both left and right. Don't forget that piece of it. The last transformation that we look at is flipping. When we have a negative in front of the absolute value, it simply flips the graph upside down. So notice the vertex hasn't moved, but it just flipped it the opposite direction. Now, the cool thing about these transformations is they can all be done at one time. So you can be moving the graph left, you can be moving the graph up, and you can be flipping it and multiplying it. You can do some or all of the transformations all at once within a function. So looking at this one, the question is, what's the transformation? Well, let's start with the vertex, okay? Because the parent graph would be up here at 0, 0. So how has the vertex moved? Well, it's moved left 2. So that's the first one. Left by 2. And then it's moved down 1, 2, 3, 4, 5. So down 5. Has it flipped? No, it has not. Has it stretched? Well, let's count the slope. So from the vertex, it looks like there's another point here. I'm going to count up 1, 2, 3, and over 1, which means that it has stretched by 3. Now let's put this all together and make a function. So we've got y equals, oops, I forgot to write my 3. So the 3 is the multiplier. So I have 3 in front of the absolute value. Left and right is inside. So it's going to be x plus 2 because remember left is plus. And then, oh my goodness. And then we're down 5. So we're going to add a minus 5 at the end there. This is the equation of this blue function here that we see on the graph. Let's try another one. So we got the transformation. So let's start with, remember that our parent function would be at 0, 0. And this new one is over here. So obviously we can see we've moved left 1. We've moved up 2. There's no flip. And I'm going to count the slope, and it looks like it's up 1 over 1, up 1 over 1, etc. So there's no change in the slope. So if I want to write the equation, I'm just going to write the absolute value of x plus 1. Sorry, that's a plus sign. Plus 2, because it's up 2. And that is the equation of the function. So hopefully you're feeling like you can transform graphs of absolute value, both with the equations as well as with the graphs, and kind of put the two pieces together. You will have some practice doing this and then being able to tell the different things that are happening.